All right, looks like we're rolling. Check, check, and here we go. All right, 7.1, first lesson, chapter 7, angles of polygons. Okay, so, start of a unit, some vocab to go over. There's a lot of little things, but no like huge, crazy difficult problems that we're gonna have to deal with, okay? So a little bit more to cover today, but nothing that's gonna be like a 5-10 minute problem. Everything's pretty quick. Okay, so what is a polygon, first of all? All right, poly. You want to know, why is that not ready? Poly is the prefix that means many, and gon means sides. So when you hear the word polygon, it means many sides. Okay. Now, in terms of math, it's really any shape that has any number of sides. It could be a square, could be an octagon, anything. Okay. So it's something that has straight sides, no curves, just flat edges or sides on it. All right. So we're going to talk about some polygons. Now, think about this. Can you draw a polygon with just two sides? Okay. Could I do it? No, there's no way to connect them without sort of curving one of these segments. So the least amount is, so we're going to list them up to 10 we'll do, is a triangle. All right, we got 3 sides, and boom, draw yourself a little triangle, okay? Then we can work up from there. So next one is 4 sides. It's not called a rectangle or square. That's actually more specific than what we need. So we'll get to that later, why that's different. But it's called a quadrilateral. Quad meaning 4. All right, quadrilateral has 4 sides. And draw yourself a quadrilateral, okay? Does not need to be a square. All right, next one, 5 sides, pentagon. Okay, pentagon, 5 sides, draw yourself a little pentagon. And then we have a hexagon. Hexagons are very nice shapes because they fit together very well. Even like board games and stuff like that all the time. 6 sides. Next one is called a heptagon. This is kind of difficult to draw, but 7 sides. So I'll do something like this. I don't know. Looks kind of odd, but it's a heptagon, 7 sides. Then we have an octagon. Oh, by the way, heptagon sometimes is called a septagon, kind of like September. Octagon is 8. And just like the stop sign. Yeah, there you go. Good enough. The other 2 over here. Oh, and by the way, this is like September and October. Sept means 7 and oct means 8. So you might be thinking, why aren't September and October the 7th and 8th months of the year? Well, they actually used to be before the Romans changed the calendar and inserted July and August in there. So they got bumped up from 7 and 8 to 9 and 10 because they inserted those months. Fun fact. So they used to match up with 7 and 8, be the 7 and 8th months. All right, 9 sides is called a nonagon. Nonagon is 9. Another one that's difficult to draw. Oh, that's terrible. All right, just imagine that looks better than it is. 9 sides. And I don't even know if I'm going to attempt this one with this space that I have here. Decagon is 10 sides. I'll draw it bigger so I don't mess this up. Okay. 4, I think that's 10. All right, doesn't look very good, but 10 sides. All right, 10 sides. Now, anytime we have more than 10, we just use a number. So for the next one, we'd call it an 11-gon. That just means a shape with 11 sides, then a 12-gon, 12 sides, and so on. Okay? Now, there is a word for 12-gon, dodecagon, but just to keep it simple, anything above 10, we're just going to call a 11, 12, 13-gon, so on. Okay, so those are the names. Maybe you knew all those. Now, what we're going to talk about is the interior angles. Now, we already talked about how for any triangle, so it's 3 sides, this is a triangle. So I want you to copy down this table because we're going to fill this in because it's going to help us see a pattern here. For any triangle, we know that the angles, all the interior angles, all 3 of them have to add to 180 degrees. Okay, that's just a fact of a triangle. If you think of this is a quadrilateral now. Let's just think of a square, right? If I had a square that has 4 90-degree angles, that would add to what? 90 times 4 is going to be 360, so that would be 360 degrees. And that's true for any quadrilateral, that they have to add to 360 degrees. Now, I'm not going to have you measure for a pentagon, see what it is, but the pattern actually continues where each time it goes up by 180. So 180, we got 360, we got 540 degrees for a pentagon, and then we can continue from there. Why don't you fill in the rest? Just add 180 each time. So 720, 900, 1080, and what is that? 1,260 for a nonagon. So if you add up all the interior angles, right, all the angles inside the shape, this is what it'll add up to for each shape. It goes up by 180 each time. Okay? So if I were to take a octagon and add them all up, they should add to 1,080. In fact, they will every time. Okay, so what can we do with this information? All right, every time it's going up by 180. Now, I want you to notice something. Right here, we have, just different color here, we have 1 times 180. Here, we have 2 times 180. Here we have 3 times 180, and so on. 4 times 180. Now here's how this is useful. We can take the number of sides and plug it into an equation to figure out if it was a 20-sided shape, what would be the sum of its interior angles. Okay, so here's how this works. Notice the relations. Go 3 to 1, 4 to 2, 5 to 3. Each time we're subtracting 2 from the number of sides. So let's say this. We're going to write the polygon interior angles theorem. You have to know why your textbook writes it the way it does. First thing you need to know is that for this theorem, n is the number of sides of the shape. So a triangle would be 3, quadrilateral would be 4. So what we're going to do is we're going to take n minus 2. So we're going to say n minus 2. So like 3 minus 2 is 1. And then whatever you get, you're going to multiply it by 180. Times 180. Okay? That is your equation for the sum of the interior angles. Okay? So this is the sum of interior angles. So right here, this is what you need to remember. N minus 2 times 180, where n is the number of sides. So if I had a 20-sided shape, I would do 20 minus 2, and then multiply to get 18, and then times it by 180. Okay? So we could try that out with an example here. So make sure you have this, put a star by it, circle it. Don't lose that. That's an important equation. All right. Let's find the. So okay, let's pretend we didn't just list all the angle measures, and let's look at what type of shape this is, and then find the measure of the interior angles of the figure. Okay, you can copy this down if you want, but the main thing is this is what type of shape? 1, 2, 3, 4, 5, 6, 7, 8. This is an octagon. Okay, so you can copy down if you want, or you can just say it's an octagon. Doesn't matter what the octagon looks like as long as it has 8 sides. All right, so we got n minus 2 times 180. What are we going to put in for n? Well, that's the number of sides, so that's going to be 8 minus 2 times 180. So really, we're taking 6 times 180, and that will tell us the sum, all these angles added up, what it should be. So, get out your calculator, 6 times 180, and we get 1,080 degrees. Okay. Now this should match up. We used kind of a smaller number of sides here. This should match up with what we just did right here. Yep, 1,080. Everything matches up. Good. All right. So let's look at another one here. Why don't you try this one on your own? Okay, we got an 11 gon. So this is a Canadian coin. They have 11 sides on their coins. Find the sum of the measures of the interior angles. Okay, try that out. So we're going to do 11 minus 2 times 180. So really we're doing 9 times 180, and that will tell us all of those angles added together. 9 times 180, get your calculator, and we get 1,620 degrees. Okay. Yeah. So that's pretty straightforward. Plug it in, and you get your answer. Now, let's talk about working the other direction. Okay, so you want to write down this example. The main thing here is that the sum of the measures is 900 degrees. Okay, so make sure you know that the sum is 900. Now we want to classify the polygon. Okay, so I'm just underlining the key parts that you want to write down in your notes. The sum is 900, classify the polygon. So we know that the sum equals n minus 2 times 180. We do not know the number of sides, but we do know another part of this equation. We know the sum is 900. So what we can do, and this is another one that's in your table. They won't always be these small of numbers. So they won't be on your table always, but this is a good one. You can look back in your table and check if you're doing it right. The sum has to be 900 degrees. So we can set that equal to n minus 2 times 180. And hey, this is something that we can solve now. All right, now you have choices on how you solve this, all right? Personally, the way I always do it is I divide by 180 first. However, you can distribute the 180 and then solve that way. You get the same thing. But I'm going to divide by 180 first. So let's do that. So we divide by 180, divide by 180. And it spits out 900 divided by 180. That's going to be 5. And then these cancel out. We get n minus 2. Okay, we just got to add 2 over, and we get the number of sides equals 7. Okay, so if it's a 7-sided shape, we need to know the name of that. And a 7-sided shape is called a heptagon. That'd be your answer. All right. You don't always have to show this much work. I know some of you guys do 2 steps at once, but show where you start, right? 900 equals your equation, and then you can go from there. All right. We already talked about this, but it's kind of a fact that you need to know going forward. The sum of a quadrilateral, you can always figure it out, right? If you forget, you can do 4 minus 2 times 180. But it's just really useful to know. Like we said before, if I had a square, you can quickly add up all the 90 degrees and get that it's going to be 360 degrees for that square. Now, not every quadrilateral is a square, but it's still true that they have to add to 360. So the angle sum of quadrilaterals is 360 degrees, okay? Just like before when we said triangles are always 180, and then we just assume that fact going forward. It's true for every triangle. We can also assume that for every quadrilateral because it's always going to be true. All right, with that information, you're going to be solving for some missing angles. We know they have to add to 360, right? So, okay, why don't you jot this picture down, and then we're going to find x. So if we're trying to find x here, we don't have to add to 360, so essentially it'll look like this. It'll be x plus 108 plus 121 plus 59. So all of them added together have to equal 360. All right, and then it's just a matter of combining your like terms and then solving from there. So most of these problems you need a calculator, so if you don't already, you should already have one out, but use your calculator, combine these, and then see what you get for x. Okay? I will do the same. So add them together, 108 plus 121 plus 59. I get 288 equals 360, and then I'm going to subtract from 360. And I get x equals 72 degrees. There you go. So that's it. They added 360, so you just set up an equation, subtract. Some people won't set up the equation, they'll just do something like this. 360 minus 108 minus 121 minus 59. That works fine if you just subtract each of them and then you get your 72. However, when we get to the point where there's multiple missing angles, you're gonna need to set up an equation like this, and we'll get to one later like that. So this is fine when it's a simpler problem, but when they're more complicated, you're gonna want the equation. All right, so all right, now we're going to look at this one. We already did one like this. Why don't I just have you try number 4 here? This is another one where you just set it equal. The total, the angle sum is 1440. So that has to equal n minus 2 times 180. So we'll just do this one quickly, I guess. Classified. So you want to pause it here, do this one. So we're going to 1440 divided by 180 and then plus 2. See what you get. So I'll do the same. All right, we get 10, so this is called a decagon. And we'll talk about this word convex in a second here. Well, this is what I mainly wanted to do, so let's do this now. All right, why don't you try this one? Try to find x. You can either just subtract, set up an equation, however you want to do it. Here's the deal, guys. So many people leave out this 90 here, this 90 degrees. There are still 4 angles we have to include. So this is 90 degrees. Make sure that's in your equation, or if you're not using an equation, you subtract 90 as well. So 74, 141, 90, and some other mystery number have to make 360. So crack out your calculators and add them up. Now we get x plus 305 equals 360. We subtract and we get x equals 55 degrees. Bingo. All right. Okay, so that's that. Pretty straightforward. Just remember, if they give you the angle sum, you have to solve the reverse order, divide by 180, add 2. There we go. All right, now, what if we get something crazy like this, okay? You will get some where you have multiple missing angles. So let's just draw a picture of this. We have the interior angles of a quadrilateral are x, 3x, 5x, and 7x. Find the measures of all the interior angles. So let's draw a picture of what we got going on here. So let's say this is x, this is 3x, this is 5x, and this is 7x. Obviously this is not to scale, I'm just sort of filling in 4 angles, and we'll see what the numbers spit out here. So, how on earth would we solve this? We don't know any of the angles. Well, we do know that the angles all have to add up to what? They all have to add up to 360. So we can set up an equation. This is what I mean by you have to set up an equation eventually. We can set up an equation like this. So x plus 3x plus 5x plus 7x. All 4 of those have to add to 360 degrees. Okay, we've got 4 x's. They're being added together. They're like terms, so we can combine them. So it's 1 plus 3 plus 5 plus 7. That's 4, 9, 16. Okay. So we end up with 16x, if we add them all together, equals 360. All right, well, that's an easy equation to solve. Divide and we're done. And we get x equals 22.5 degrees. So, we are not done. If you read the directions, there's one word that makes it so we're not done. Well, I guess not one word. All, and they want the interior angles. So they want all 4 of those to know what they are. So this one here, this is just x. So the first one's going to be 22.5 degrees. Okay, good. Next one is 3 times that. So multiply that by 3. 67.5 degrees. All right, then we take 22.5 times 5 and then times 7. So go ahead and do that. Let's see what we get. There you go. 112.5 and 157.5 for the other two. Okay, nothing wrong with decimals. You will get them from time to time, and the more complicated problems get, the more likely it's going to be that you end up with a decimal. All right, so if you want to check and make sure you did this right, these 4 should add up to 360. If they don't, you did something wrong. So let's try this out. Let's do 22.5 plus 67.5 plus 112.5 plus 157.5. 360 works out perfectly. All right, good. So that is what to do with quadrilaterals. Okay, we got to talk about these words convex and concave. Convex means that no angle is greater than 180. Okay. Okay, how can you have an angle bigger than 180? Okay, let's draw let's do a convex one, and then I'll show you when that might not be the case or be concave. Keyword here is cave. It sort of caves in on itself. So this would be convex. All these are going to be less than 180. So remember, 180 is a straight line, so they're going to be sort of less than being a straight line. And concave means that there is at least one angle that's greater than 180. At least one angle greater than 180 degrees. So what that means is, let's start this shape the same way, and then all of a sudden, we do not go out like we normally would. We sort of cave the shape in on itself, like this. That would be concave. Because if we look at this angle right here, this angle is going to be, the interior is going to be more than 180. because we're measuring around it like this. Okay? If you don't remember that, just think of the word cave. It caves in on itself. That's concave. All right, regular polygon. I think this is the last vocab word we got to learn. Well, maybe there's one more. Regular polygon means two things. The sides are congruent, and the angles are congruent. So, two very common regular polygons that we don't call regular because they have their own names are, we'll draw them down here. This is a regular triangle. All the sides are the same and all the angles are the same. And we have a word for this because it comes up so much that we've made a word for it. It's called equilateral. Okay? Equilateral triangle. What about a regular quadrilateral? We also have a word for this. So let's draw a regular quadrilateral. All the sides are the same, all the angles are the same. What do we call that? Well, if all the sides and angles are the same, it's just called a square. You do say quadrilateral, we have a more specific word, square. There's no word for a regular pentagon, right? So if I were to draw a regular pentagon, we don't have a special word for that. I'm going to try to draw one here. So if all of these are the same, we would just call this a regular pentagon. Okay? All right, so that vocab out of the way. I don't want to do this one. We're going to skip this one. Okay, let's talk about this one. So, and we're not going to worry about this one down here. For number 6, they say they want us to find M and S. Or sorry, S and T. Where we got M from? So, okay, we have a pentagon. So we have to know, first of all, what are all those going to add up to? How can we figure out the missing ones? And also, these are the same. So we should be able to figure out what's missing and divide it by 2. Okay, let's figure out what they should all add up to. Okay, remember, our equation, we're figuring out the angle sum is n minus 2 times 180. So how many sides do we have? We have 5 minus 2 times 180, which is really 3 times 180, which is 540. Okay, so we know that all of these have to add to 540. Now, anytime I don't know something, I'm going to call it x. You don't really have to. You can subtract with this one, but like I said, an equation is the most surefire way to solve these. So I'm going to say that 93 plus 156 plus 85 plus x, and I'm out of room. All of this, these 5 angles have to add to 540. So since they add to 540, we can solve this now. We got to combine our like terms first. So why don't we get a calculator and add those up? And then we'll solve from there. So we got 93 plus 156 plus 85. I got 334. And I can combine these two x's to be just 2x. All right, should be able to solve from here. Let's subtract the 334. So we get 206 equals 2x. And we can divide by 2, and we get x equals 103. Okay. And they're the same, so they're both 103. So you will get some tricky ones like that where it's not a quadrilateral. We don't know its angle sum right away. So you're going to have to use this to figure out the angle sum. Then you'll plug it in to the to an equation to solve for the missing angle. Okay? Or really subtract to find the missing angle. All right. Last thing I know, like I said, there's a lot we have to go through. Last thing is exterior angles. It's the simplest one, but people kind of forget about it because it's sort of tacked on in the end. All right, exterior angles theorem, the sum of the measure. Actually, let's just do it this way. I have a much quicker way to say this. Exterior angles. So if I have a triangle, okay, and I extend out each of these sides like this, let's call this 1, 2, and 3. We would say that 1, 2, and 3 are exterior angles. And here's the key fact. They always add to the same number. It doesn't matter if it's a quadrilateral, pentagon, octagon, dodecagon. Exterior angles add to 360 degrees. So typically in geometry, we have a lot more like 180s we deal with. In this lesson, there's a lot more 360s, which isn't far off, but it's just a fact that we're going to have to get used to. Quadrilaterals add to 360, exterior angles add to 360. Let's look at this. So they tell us that we have these 4 and we're missing 2 of them. So we got to set up an equation. We know that all 4 of these have to add, doesn't matter what type of shape it is, they have to add to 360. So we're going to say 360 equals 89 plus 67 plus 2x plus x. I can combine my like terms. So I get 89 plus 67. I get 156. So 360 is 156. This will be 3x. So now I can subtract and divide by 3. And I get 68. Okay, so they add to 360. Let me see how much time I have. Okay, we're good. They add to 360, so you can just set up an equation like this and really just subtract and divide. Oh, time is short. Last problem. All right, we're going to do 2 things. We're going to find the measure of an interior angle and an exterior angle. So we have a dodecagon. N equals 12. And what we're going to do is we're going to say, what are we going to say? So it'll be n minus 12. Not n minus 12, sorry. 12 minus 2. So our n value is 2. So it'll be 12 minus 2 times 180, which is going to give us 10 times 180, which is 1,800. Okay, so this is our interior angle sum. All right, so if we know that that's all of the angles put together and it's regular, all the angles are the same, all we have to do is divide that by how many sides there are. So if there's 1,800 total, and one of them is 12, well, there's 12 of them total, so I just have to divide. Here's my calculator. So I do 1,800 divided by 12, and I get each one is 150 degrees. That's for interior. And for exterior, I know they have to add to 360, and there's 12 of them. So 360 divided by 12, and I get 30 degrees for my exterior angles. Interior angles and exterior. So for interior, there's 2 steps. Find the total and then divide by how many angles there are. Okay, it's kind of a lot, but hopefully you stuck with it, and see ya.